Hello everyone and welcome into yet another live stream. Today we're going to be walking and walking. How exciting! We'll be doing both. Hi the Krish, hi the Olo, hi the Zentre. You are right. Being first is important. You win the live stream. Those are the rules. I don't make them. Anyhow, I'm actually already rendering stuff in the background, so music might need to be a bit louder. There we go. I'm already rendering animations in the background, so this time we're not starting with rendering, we're starting with coding. This is what we did last time, and we managed to display an image. And today what I would like to do is I would like to automate image displaying. Make it remember me. Yeah, I don't have that short of a memory, people. I mean, I know I often say I have a memory of a goldfish, but... No, okay, this music is a bit loud. There we go. There we go. Alright, so last time we displayed an image, and this time I would like to automate in a way to make it better, pun intended. So, first of all, actually when it comes to the image, we should change up the shaders. We should change them up because we should make... Yeah, we should add like a matrix, 4x4 matrix for transforms, so we can transform the image. Well, to be fair, that probably would be a pretty minor change in the future. Okay, so basically, what I would like to do is I would like to make a function, which is just like a create image function, and that's it. You should make it. I don't get that. But you know what? I should make it. Oh, there's my cup. Okay, my cup of coffee was just hanging out on the edge of the table. Or the desk. Depending on how one does, I suppose. You don't understand any of this, or am I just dumb? Any of this code? Yeah, it's reasonable. I mean, the fact that you don't understand it is reasonable. I'm the one who wrote it, right? The thing is, it's this common misconception, actually, that when it comes to programmers, people expect programmers to just look at some code and already understand what it means. That's not important. That is really not important. So far, yeah, not so far, only no one will really understand it unless they actually go through it very slowly, so don't worry, Zentre. And hi, Vernon, hi, welcome. Alright, so, a function, I feel like init would be, actually not init, we should make another thing for this. Like a render C and render H. And then here's what we're going to do. We're going to include main, that's important. And also right here, include render H, which is funny because this includes main, which means we're including main, and including main 3 times in a row. But fortunately, because I'm a very clever boy, we just figured out a way around it. What do you mean? I mean that, like, code, especially in C, is not as trivially readable as people think. Which means, in order for me to explain how this works, that would take like 10 minutes, but in order to actually get everyone through the code, that would take like 2 hours. Maybe 3. Alright, so, render. For render, we're going to create a function like this, which will be render. Oh no, that's not a good one. MAKiT create image. No, MAKiT will be left for MAKiT client create image. There we go. That'll be our new, well, semi namespace. Not really a namespace with classical standards, but it's what I use in C. Why's my keyboard so weird? Alright, MAKiT create image, to which we'll give well, ideally we'd like to give it a string, wouldn't we? Hi Zen. Hi the Roxana. Hi, welcome. Joining right now, yeah. That's pretty standard for the streams, I would say. All right, create image, on a constant char pointer. I believe that's strings. So file. That's a bit annoying. Hold on, actually, when we create image in init, right here. Oh, we already have GL create image. Oh yeah, but that's not the right create image, is it? It is the right create image. Wait, what am I bitching about? We already have a create image function. Why would I need another create image function? We already have a create image function. We already have a perfectly fine and functioning... Well, the render will stay here because we will need it in the future. But we already have a create image function. Shouldn't the create image function just walk? That's it. MAKiT, how old are you? That's a good question. Wait, create image GL parameter I. Yeah, I mean, it's already creating the thing. The only thing I would like to add is a constant char pointer, which will be file, like this, and then right here would just give it the file, because I'm pretty certain there's a constant char pointer. Sweet. And then in order to do it properly, we need to go to init and we need to do this. And now right here, GL create image we have here, and then we give it the test source, and then MAKiT.png. No, don't code. Yeah, the code's not looking for. Build. There we go. 1 divided by 0 times 0 years old. That's true. Yeah. Actually, exactly how old I am. Would you look at that? It even works. How sweet. I did always. I wouldn't say so. I'm here. I'm the one who overuses jokes. And now, oh my goodness, we actually already got the image loading. Oh, damn it. I was honestly expecting it to take a bit longer because now at this point, I guess we can have a loop for like rendering all of the images. What do now? It's a loop for creating, I mean, okay, yeah, loop for rendering all of the images now, I suppose, would be next. And then after that, the transform matrix. Okay. What happens if we load in a PNG image, actually? Because right here in the init C, I mean, we have GL create shader. No, that's the wrong one. GL create image. And right here we load in the image using the stb load. Nope, it just figures out by itself. Oh, this could be broken. Can you explain how heat can be created from a chemical reaction? The explanation always gives that energy is stored the bonds and that the energy is released as heat, but no one ever explains how. Zentre, I have a question first about the background. Have you perchance mayhaps seen my Electron video? Because if you've seen my Electron video, it will be so much easier to explain this. How can a chemical reaction make molecules? I have not. Well, that's a pickle then. Zentre, that is your... Okay, your homework for today will be to watch my Electrons video. Because my Electrons video... I'll go watch it right now or later. Because if you want, you can go watch it right now, and then when you come back, I can just give you the explanation. I will then be back. Alright, Zentre, go watch it, and then when you come back, I'll explain. We don't take a nap, Terry, and make us a main. That's true. Elliot added the rule. No sleeping, if I'm not mistaken. Is that the rule still up? No sleep for anyone. Yeah, it's still up. No sleeping. Sorry. No, I don't make the rules. I quite literally, in this case, don't make the rules. That's Elliot. Who am I to question Elliot's judgment? I'm just the guy who owns the server. Okay. Oh yeah, we can also get rid of all of this. Just like things we save for... Oh yeah, and we can also get rid of the print. We can get rid of all of these, because they... Oh, image free! Yes, that's important. That's really important. Alright. It is quite important to free the data for the image. Sweet. It works. Is this Python? No, it's C. You see, it's C. Alright. I need to get a JPEG to test. What would be a good JPEG? Something good. Oh. Look at my files. Do I have any good JPEGs? Open muscle. I like that. I'm gonna use open muscle. I just randomly opened a JPEG with that name, okay? That was a coin flip. It could have been anything. Whoa, I actually regret whoa. That was a pretty dumb of me to just open a random image on my PC on the main screen. But okay, let's do it. Now, we should just be able to switch this to open muscle and then JPEG, and this should work. Okay. So it won't. Okay, I see. What if hypothetically we change this to just RGB? Okay, cool. So, okay, that's pretty bad. What if we change this to RGB? I see. It's broken. Okay, well, that's something. C is my favorite programming language. So is mine. I love C so much. Okay, let's print... Wait, GL create image has to be loud. There we go. Let's print the number of channels. How about that? I feel like that's a perfectly swell thing to print. We get 3, which makes sense. Makes sense. No, it should be 3. That's good. That's correct. Why's it broken? Is it because the shader is actually expecting in... No, it's expecting in a color. It's just expecting a texture uniform sampler to the... Okay, so it works with PNG files. Can I just have every file be a PNG file? Can I just only load in PNG files? I feel like that would be such a much easy thing, you know, just if we could just only load PNG files. Such a simple solution to this problem. But the engine will just only support PNG files because that's the only one that works. Alright, let's... There, here we have the background, one of the backgrounds. Just a... Oh, and here we have another. Oh, this is nice. Oh, this one has alpha. That's great. Oh, hell yeah. Pi. This one has alpha. That would be a great test if alpha works. Ooh, yes, absolutely. I would love to check if... you know what? Actually wouldn't, because it might break. Might break, so... Okay. So... This shouldn't be black. This should be grey. Okay. You forgot about sulfuric acid. They are my favorite beverage of choice. So I can at least code it. I can always code it. Just give me a sec. I'm warming up. Why is this? Why is this? Why is this? This is RGB alpha. Okay, so it's instead of doing alpha, it just does black, which is not great. It's not what we're looking for. Ain't nothing nothing but a heartache. I don't wanna hear you say I want it. Okay, why isn't it walking? Very important question. GL texture 0, we are loading the right texture. And it's, well, it is walking, just not walking the right way, which is the most annoying kind of error, because if it was just an error, that would be simple enough, you know, just fix the error, but it's not an error, it's just mildly... Eating hydrochloric acid, technically true. I mean, I guess it is. I guess technically it is true. I mean, okay, if you think if you think of fluids as reacting with themselves, then I guess you are eating hydrochloric acid. No, I'm lost. I don't know why it won't be working actually. You know what? Let's ask the internet. Internet always has great ideas. Not only great ideas. Open GL texture with alpha. How would I make it happen? Tutorial number 10? Oh, because we're doing out vector 3, aren't we? Are we not? No. Yes? Wait, out vector 4. 4! Yes, you are right. Oh, it's not gonna work now. Wait, there is no way I can just switch it from 3 to 4 and it's gonna work on the first. Okay, this is much better than I was expecting, honestly. I was just expecting it to disappear. Alright, is it because we're initializing the shader the wrong way? Attribute pointer, bind buffer. Oh lord, shader program, yeah. Right here we're doing the vertex shader, linking the shader program, and then... Wait, is it in the main? It absolutely is not, okay. Why do you use DuckDuckGo? Because I don't have to solve a captcha every 3 seconds. Bind buffer data. It's going to be a fragment shader problem, if it is a problem. I'm pretty certain it is. Fragment shader problem in which we attach the shader program and then we link the shader program and then it just walks apparently. Except it doesn't. The music is an absolute pop. I like it. Also, right here we're just generating vertex arrays, binding with the array. I guess this one's also 1. Oh my goodness, I'm gonna have to start looking stuff up, won't I? Just... Oh wait, transparency. Color A. No, not looking for, no one looking for. Blend function. Can I just wait, hold on. If out vector 4 should fix it, then why isn't it fixing it? Well, I guess that's the question, obviously. Love your channel. Please learn how to pronounce the R in Warg. It makes my life 50% worse when watching your videos since Warg is such a prominent concept. 6 nades. I've tried, okay? It's not a choice of mine. I'm cursed to this existence. I know how to pronounce R. I just... It's a mess. I could roll it if you want. I could say work. If that makes it better. Is it because we input it as a 3? No, we want to input it as a 3. Yeah, the color is different. But out our color. And then right here we can do vector. Oh wait, how is vector done? Can I do vector 4 like this? If I can, that would be impressive. Okay, didn't break. That's something. Wait, what happens if I break this code? Is it gonna... It should break. Right? Yes. Okay, good. Which means this is actually working properly. And if I switch this to 0.5... How about now? Oh, I see. So the alpha isn't working. I don't... Well, maybe it might be working actually. Oh, because we don't use our color in this. Okay, well, yeah, okay, that explains it. Can I do frag color is equal to frag color alpha is equal to 0.5? I would know. I mean, no, y'all are pretty confident sitting there in chat, typing it in. I'd like to see y'all trying to pronounce it. Is it because of the blend? It might be because of the blending. Stop your blend function. Okay, you know what? I'm just going to enable you. I mean, to be fair, enabling blending sounds like a pretty important step. Right after clear color actually should be fine. Oh, I'm a genius. I did it. Yes. It worked. Oh, I'm so handsome and incredible. You all are welcome. Always better make it, yeah? Hell yeah, that's a rule. If anyone bets against me, it's getting banned. Okay, so now that we have the alpha functioning, the next thing to test will be 2 images at once. Let's see. Okay, we can set them up as 2 images at once, that's nice. Now, right here we can bind the texture, and so what we can do is we can take this, and if glfw get time is greater than 4, and now if we build it, no wait, if, no that's wrong, else, and then we can right here bind texture to 1, and now if we build it, and then if I am a good programmer, then if we turn it on, oh, I am amazing. Okay, hell yeah, it's actually really good. That's actually really good. So basically, what we did here is We said number. Oh, that's proper good coding. You're all talking about in chat. No, I didn't force it. I'm just reading your messages and I'm, well, a bit disappointed if I'm honest. All right. Okay, great. So this is working properly. That's nice. Well, now at this point, well, matrix transform with images. For this, I am going to use a tutorial because that would be so much easier. We won't have to matrices here, but a specific matrix. We're looking at the translation process. There we go. That's because, first of all, there might be... should we implement the math ourselves? Fine. There is a GLM, like a library, which can handle that for me, but... Well, I mean, you would need a separate... Oh, right, yeah, fine. Int transform MAKiT client transform image, and then we'll give it... well, we'll figure out what to give it in a second. It shouldn't be that complex. Now we define it right here, and we also include and H. Hey MAKiT, I've been wondering this for a while now, but why is everything except the I capitalized? That's one of these secrets of the universe, which are just... mere mortals couldn't handle that knowledge actually, so I'm sorry. I'm just trying to protect you if I'm honest. I don't want your brain exploding due to the sheer divinity of this information, okay? It's... It's hard to believe it's because he had caps lock on but press shift on the I. Yeah, I just misclicked 4 years ago. And I thought, good enough, might as well. Just went with it. Can you imagine if that was actually the start? That would be comical. I mean, on the old channel, the really old one, there was like a... there was a spelling error in the name original. I spelled that and just went with it because I thought it was funny that even my way of spelling original was original. But no, that's not the reason why I is different. Okay. Well, 3D transformation matrix is what we need, and then we'll also need to figure out how to bind it into the shader. No, examples 3D. Can I, isn't there like a equation for it? Matrix rotated in angle alpha, but the axis defined by unit vector xyz is this. Okay. Theta, unit vector xyz. Okay, but there's just a single theta, which is kind of shady because Why is there just a single theta? That doesn't make much sense. Why is there a single theta? Because then as a single theta would just give you one around any axis. Defined by unit vector xyz. Oh, we defined the... Oh, that's really clever. That's really clever, okay. Maybe he doesn't like how the capital I looks like. I mean, okay, which one looks better actually? Make it the capital I or the lowercase I? In my opinion, it's lowercase. Lowercase looks nice. Actually, all of these will be defined in the... oh, we will need the matrix. Matrix OpenGL passing into the shader. Passing a matrix into GLSL shader, and how? Has my mic been off? Every now and then just clicks and then just turns off. How are they passing it actually? Varying. Wait, is that not the right question? Hold on. I can just look it up with this tutorial. How they passed it in. How would you pass it in? Identity matrix, transform vector, okay. How to pass a small amount of information to a GLSL shader. A small amount and efficiently sending values to GLSL shader, yes. Point sprites. What are those? Whoa, isn't that just swell documentation? Bro's got the sleigh goats. Can combine the use of points or another expression points. Hold on. How do you use points? Oh. That feels like an old solution. Welcome back, Zentry, I suppose. Uniform variables. Okay, no. We basically want something that we bind in every single time. So, like bind buffer, bind vertex array, or just different ways to pass information into a GLSL shader. I went towards electron video. Oh yeah, I know. So, here's the thing. When you have a chemical reaction, right? What's really happening, for example, in the video, I believe it was water. If you have oxygen, okay, lovely oxygen gas and lovely hydrogen gas, like this, then that's chemical, correct? Now, if you light it on fire, what does lighting it on fire actually mean? Well, temperature is just the movement of particles, right? So when you light it on fire, when you give it a lot of heat, what it's actually doing is it's vibrating those particles around. So these are just going back and forth really quickly. They are going so quickly, in fact, that they can bump into each other and they can just break. And once they break, so once these break, they, instead of going back to this high energy state where, you know, it's hydrogen and oxygen, they go to a lower energy state where it's water. And so you can imagine it like, you know what a good analogy would be actually? Imagine you have two different magnets, right? Just one magnet right here. One magnet right here. Imagine you have two different magnets, far away enough so that they don't attract each other. At least they don't attract each other strong enough to actually move in. This is basically a hydrogen and oxygen. Now imagine that we start vibrating them, like more and more. That would be basically how our temperature works. At some point, if we start vibrating them, they might, due to vibrations, just get close enough that their own magnetic fields will attract them strongly enough for them to just, you know, come near each other. And then they will basically come together to form, well, they'll come together to make another magnet, like this. So when we have some sort of chemical with a lot of potential energy, so chemical energy, then when we introduce heat to it, or actually there can be different things than heat, but in this case heat, when you introduce heat to it, it can cause that reaction to happen because then you have a lot of chemical energy and we basically unlock this chemical energy. And then once that reaction happens, then the reaction itself is movement of molecules. That is the reaction, movement of atoms. So atoms moving around. And movement of atoms is just temperature. So you can imagine it like, you know, the magnets, their energy is magnetic. The reason why they can move is because of magnetism. But once they actually start moving, that's kinetic energy. So when you have chemistry, when you have chemical energy, that's the potential of molecules to release energy. But once that energy is actually released, it's released in the form of movement of molecules, which is thermal energy. Is that clear as mud, or am I not explaining it well? I just realized this looks like a worried face. You know? It's like one eye, second eye, mouth, eyebrows. I don't like magnetic analogies, they don't stick well to me. But I mean, in this case, magnetism is the best analogy we've got. And then something takes my brain like a moment to process it. It's fine, that's actually pretty normal, I would say. And wait, don't stick well. Was that a joke? I didn't even register that. Okay. Passing different ways to pass information to a shader. Yes. How do you pass information to a shader? Oh, now this is documentation. Oh yeah, black and white, text in different fonts. Or with different bold actually. Oh, yes. Readability. I mean, this is nice. This is, as I always mention, I love these graphics. These graphics are great. But okay. Different ways to, how can I pass information into a shade? That's all I care about, okay? Transformations. Oh, how do they actually pass transformation information to shader? Let's see. They do it using, that's GLM, that's GLM. Using uniforms. Would you look at that? Well, I'm gonna steal it then. And in this case, the color will also pass in as a uniform. That's into, wait, that's the fragment or vertex? Vertex coordinates. That's fragment, okay. and this will also be a uniform, because we don't really need to pass in the color as, you know, anything else. You'll have to change it up. So for example, with this color, we can just remove this, and then in the init, we can remove it right here. This to be 3, this to be 1. There we go. Now that should be fine, I think. If we build it, actually we're not passing a uniform, so a uniform will be just the garbage value, but at the same time, never mind, it broke. Okay, well, why did it break? Just out of curiosity. It's not like I care about anything, just out of curiosity. Why did it break? Okay, so, that's cool. Is that why? That could be why, actually. Let's see. Nope. I know why, because we still have this. That's why. Okay. That's why it breaks. Okay, not quite. I should be getting closer though to the answer. Okay, so into GL create shader, we pass in these, pass them in right here, and then we should create shader. So right here we pass in vertices like this. The size is all wrong. Wait, is the size? Yeah, the size should be all wrong. Because now we have... Right here, we pass in 32 and 6, but this shouldn't be 32. This should be 5 times 4. Which is... 5 times 4. Wait, this is 8, but this is... 8 times 4, yes, okay, so wait, we just pass in a number. Fine, whatever. Fine by me, 20. I'm just going step by step instead of fixing the whole issue, just fixing it one by one. Where do we pass in size of vertices? We pass it in into these, so buffer data for example, and size of float times this, that's correct. Indices shouldn't be a problem. GL buffer. It's the relevant GL buffer. That's really odd. Because we have this, which is bound to a color. And then we have this, both of which should not, well, they should this one should exist, just that this one should be 1.0, 1.0, 1.0. Okay, that wasn't it either, alright, fine. R color, we're passing in R color. That's because we this time didn't have out on R color. No wait, this is a uniform. Ah, oh, that makes the problem worse. Yeah, so this should be... Oh, because this is getting in R color. That's such a mess. Okay. R color. And then right here we want to output R color. Yes, we want to output R color. What's this? That's irrelevant. Okay. We want to output R color as a 4. And then 1.0, 1.0, 1.0. And now we want to delete this, want to do this, and we want to do this, and we want to do this. Curious, alright. That's interesting. So, alright. What happens if we delete the uniform? It's kind of loading it, but understanding, I don't understand. I think I have to watch extra video again. A great video though. Thank you. I mean, if you don't understand, I can try explaining it again. Imagine it like a ball rolling down a hill. Then, if not magnetism, let's go for classical mechanics. Imagine you have a ball, right? Ion or onion exists because if an atom has an NM of protons, you have NM of electrons. I can have more electrons. Zentre, I am so fucking glad you asked that question because I've been confused. Back when I was in school, even I was so confused with how ions could even exist. So unbelievably confused. So I'm really glad you asked the question. Now, back to the chemistry, for example, for a second. Back to the how can reactions create heat. Imagine you have a ball like this, all right? This will be our particle. So our atom, basically. You have a ball like this, and it's just staying on top of the hill. It's fine, it's chill, it's good. But then imagine you push the ball forward a bit. Once you push it, it rolls down the hill until it comes to another state, right? That's all clear enough, correct? I mean, just the ball down the hill, right? Ball going downhill, it's simple. Chemistry, for chemistry is the exact same thing. So you can think of it this way. You have atoms, which are in a certain position, but they would really like to be in another position. So with less chemical energy, like this. This is our ball up the hill, and this is our ball down the hill. Now, once we give them a little bit of heat, so basically heating them up, making them move, they, just like this ball rolling down the hill, they roll to another position. In this case, they go from hydrogen gas and oxygen gas to water. And that way, they create movement when doing so. When transitioning from a higher energy molecule to a lower energy molecule, they just move around to actually do it, right? These atoms have to move around to actually get to these places. That's the movement, and movement of molecules is what? That's temperature. And endothermic reaction, right? Wait, no, exothermic. I have no clue. I didn't ever bother to learn endothermic, exothermic. It's pointless. I just say releasing heat or absorbing heat. That's so much easier. Endothermic, exothermic is just... people. It's used either by professionals in the field or people who have really big ego. If you ever see anyone saying endothermic or exothermic, if they're not a professional chemist, that means they're just trying to flex. For professional chemists, I understand, they just use it because it's shorter. Yeah. And when it comes to ions, I am so glad you asked. You see, when it comes to ions, there is actually nothing wrong with them having charge. So that's the problem. What you have to understand is that the rule of an atom has the same amount of protons as electrons. Actually, wait, hold on, let me ask something. Have you seen my chemistry video? Because actually, I just realized the beginning of the chemistry video is... Listen, Zentre, if you have some questions, I really recommend watching my videos. I have videos about a lot of stuff. Like, I have a chemistry video. Chemistry. So which, like, on the very beginning... Well, there's our orbitals, but on the very beginning I explain number of neutrons and the number of neutrons. So let's remember, they are both really similar in appearance. I think. Now something is where's the ions actually? Somewhere around here. Plus, the point is, it's in this video. We have mass number, atomic number ions. Now for watching back, yeah, essentially. I mean, why do you all watch my videos? You know what I should do? I should change up the name of this video to like Basic Chemistry Explained or something for 2 weeks and promote it and see what happens. We'll do an experiment. So don't apologize, it's fine. It's fine, I just, you know, I just find it funny. MAKiT, can you copyright strike the stream since you showed your own video? Oh no, wait, what if MAKiT copyrights my... oh wait, what if I get copyright strike from MAKiT actually? That's a good question. I did just content steal their video. Oh no. Ionic bonds are stronger than covalent bonds. Is the stronger material an ionic bond instead of a giant atomic lattice, or whatever it's called? Wait, what did you just ask? Hold on. Since ionic bonds are stronger than covalent bonds, first of all, are they really stronger than covalent bonds? Because how would you measure that? Covalent, because when it comes to ionic bonds, like, they're not, you don't have atoms bonded together when it comes to ionic bonds. The thing is, I mean, maybe there's a research paper on that topic, and maybe that research paper explains it properly, but hold on, my taskbar just broke again. I need to restart though, there we go. Also, my animation's finished rendering, so we should also work on these temporarily. Yeah, we can set up this one to render. But maybe there's a research paper discussing this, and maybe scientists have it defined in some better way. But as an amateur, I can explain why it would be difficult to measure, at least. So yeah, for a true source, true answer, I would recommend looking up a scientific paper discussing that sort of problem more. But when it comes to ionic bonds, it's more like you have red atoms, right? You know, that would be actually easier to show this in Blender. So, for ionic bonds, if Blender starts to load... Oh, is that the wrong version? That's version 3.2.1! That's way of a wrong version. I mean, Blender 4.2, we're not animals. Finally get to use that website. I mean, here's the thing. For ionic bonds, you have an atom A, which is just going to be red in this case. Oh, Blender, come on, get over it. I only have 4 of you open, or 5 because I'm rendering. Sweet. And then you have it encased basically in blue atoms. Like this. This is obviously in 2D. In 3D it would go also up. And then you have those blue atoms encased in red atoms. Like this. And so on and so forth. The point is, in this case, you don't really have a bond between atom A and atom B. You just have all of them attracting each other and pushing on each other and pulling on each other so that they just form an ionic bond. However, when it comes to covalent, it's different, because when it comes to covalent, you just have 2 atoms bonded together. Or 3 sometimes. So in covalent, you do have just atoms bonded together using electrons in the middle. This is actually a spectrum of how localized the bonding is, where you have covalent on one side, then you have ionic, and then on the opposite side you have a metallic. For metallic, it's just atoms together with completely delocalized electrons. So, extratic attraction force, what it's called. Yeah, so this would be just different forces at play. As I mentioned, I don't know which one is stronger. I haven't done any research into that direction, but... Alright. Let's have the animations. Might as well, since we're already here. Mostly relativistic quantum. Look how nice this render is. I mean, oh, that's just sweet. Mechanics. And then you just move on, never going back. I forgot to adjust the shucks. I forgot to adjust the forgot to adjust the focus. Whoops. actually this one. It should be walk and walk, to be honest. Roxana, I just you know, I just would like to ask you a question of, just, you know, lightly. I'm just wondering, would you like to get banned? I'm just curious, you know, I just... No, honestly, would you like to? I can do it. It's pretty easy. It's actually a single button on YouTube. It's really convenient. Remember that, y'all! It's a dictatorship after all. Alright. What's next? Wait, did we get it to walk finally or did it not? I don't think it did. Okay, it's empty. Cool. I mean, the reason why it would be empty is because... Good question. The reason why it's empty would be because the color... The alpha is one? I mean, it's actually not rendering at all. How about we only load in one image, which would be MAKiT PNG, and then in main we just disable this. I mean, then we have to wait 1 second till it actually appears, but... Yep, it's not appearing. Cool. Just to make sure that we didn't screw anything up. It's gone. Alright, cool. In init C, we have the vertices defined like this. Wait, is it maybe because right here we have the vertices, we don't have them defined right there. We have them, where do we... Oh, do we only have vertices in init C? That's so convenient. Okay, this is, correct me if I'm wrong, 20 different values. So 5 times 4. Okay. If we go down here, we input 20 each time. Of course. Huh. I mean, this should be fine. But it isn't. Why isn't it fine? Good question. That's kind of what we're trying to figure out, isn't it? Let's see if we change something, but nothing will happen. Okay, it's blank. What happens if we just like break this code? A message from who? Oh, that's so convenient. Okay, if we break this code, that's what. Oh, curious. Actually, triangle to the corner. You know what that means? That means if we get a triangle into the corner, it means that even the position of our vertice is broken. Let me also check if I got one transaction. That's actually pretty important. At location 0, we input the position coordinates. I'm really struggling with this because it's broken, but it doesn't make sense for it to be broken in any place. Right, time to look up functions exactly to double check if we did something wrong. With the attribute point. If I'm not mistaken, this should be first index general variable modified, yes. The number of components per general attribute, so right here we have vector of 3, right here we have vector of 2, that's correct. Then we have GL float and GL false, as in this should not be normalized. Then we have the stride, which is offset between consecutive generative vertices. Oh, this should not be 8. It should be 5. The music change, which means this is gonna walk. Well, it's not gonna walk with, you know, a broken shader, but it is going to walk in general. I don't even remember why we broke it in the first place. Oh, to pass in the transformation matrix, that's right. How cool that is. Wait, why isn't it changing? Oh, is it because we deleted the other one? Did we delete the other one? And also, if we did, we did. So why is it? Okay, curious. Would you look at that? That's cool. Great. Now, in order to implement the transformation, we need to we have the uniforms. Now, how do we pass the uniforms? Because now it has more than 9 degrees. We need to pass our transformation matrix to the shader though, and that's how we do it. So we do this in main. We first query the location of its uniform variable. Why do we need to query it? I mean, can we like, I don't know, just have it? Okay, so let's paste it in right here, right before draw elements, and then see how it works. So, GL get uniform location. Also reading into it, ionic bonds are the strongest out of the other bonds. I'm not sure if it's true as I didn't read it, but metallic bonds are the weakest. That's a possibility. The spectrum I drew, that was not the spectrum of strength, that was spectrum of delocalization. It makes sense for the metallic to be weakest because, well, the same reason why we get them, you know, so thermally conductive and we can bend them so easily and so on and so forth. Basically, for the metallic, they're more like, they're basically ions held together by electrons, by an electron soup, as I always like to refer to it. Which, well, electron soup doesn't, it's not. Okay, so program and then uniform name. Alright. Transform log and color block like this, and right here we like the shader program. Let's grab this GL uniform. Oh, okay. So we need to makes sense. We need to do it manually, but sea of electrons. Yeah, I prefer soup of electrons. Honestly, I feel like it paints a nicer picture. It's not a more accurate picture, but it paints a nicer picture. Okay, so we have our color. We don't have the uniforms. All right. Oh, uniforms can be pretty big. This is a sampler. All right, so uniforms can get pretty chunky. That's good to know. How do you pass them the uniforms? That's how. Sweet. Mod for transform, and then vector 4, which is color. That won't be confusing at all. Modified color. And then, once we do is we look up these uniforms, which means GL uniform matrix like this, but this won't be matrix, this will be vector, correct? Nope, this will be just 3F, 4F, V. For a V, we'll have GL in location. We just pass it in? How does it work? Oh, because the location is the other. Yeah, because the location makes sense. And then GL size count, which is 1, just 1 the uniform. I guess that's why. And then we give it. No, wait, we have to do it for matrix. We have matrix 4. Count, transpose, and float would point to the value. Okay, so this will be the value, which means right now we'll just have float temp transform like this, which would be 1.0, 1.0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14. And then we do color, which will be the exact same way. Won't be really able to test out if... Oh, what's this time? How do I define them in here then? Oh, I see, the brackets are wrong. That's... Why do these brackets work? And now we have temp transform and temp color. It's actually really nice to name color this way because no one spells it in a British way when making libraries. So this we can keep. No, we can remove the false and then just do temp color. And right here we just do this. And then if we build it, it takes a shockingly long time to build, but that might have something to... Okay, that's good. Now let's go into the shader. And let's go right here. Right here, because we'll need to figure out how to transform times vector. Yeah, then we need to transform the position. Makes sense. We did bring that transform for some reason, you know. Which, this will be just a random transform. I don't know what it's gonna do. It's gonna do something random. We don't know because... Yeah, it's gonna disappear. Makes sense. Okay. Do we start with... I don't know how a graphical transform works, so I'm just going to Wait, actually I do know how it works. Oh yeah, the fourth one will screw me over a bit. Geo position is equal to this. A position 1. Can we just go to main C and do 1, 0, 0, 0, 1, 0, there we go. 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. Okay, something like this. It's out of curiosity, you know. I'm just curious. Huh, well. Okay, so... okay, so we zoomed in. Good. Progress. That's progress. Well, is it progress? We need to know how to transform graphics, basically. 3D graphics matrix transform 4D. That's what we need to figure out. Transformation matrix for 3 dimensions. We am pretty with it. Okay. Examples 2 dimensions. No, finding matrix transformation. Ooh, maybe. Oh, lord, that's not what I'm looking for. 3D computer graphics, yes. How could I just... There are so many transforms in this case. Oh, no. Okay, what I'm looking for is the major... Okay, here's what we're trying to achieve. We're trying to achieve... transformation in which... our coordinates, which will be basically something like 0.5... and then the 0.2, 0.7 and 1.0. This transformed by a matrix. That's how professionals do it. This transformed by a matrix like this. Oh, MAKiT 2, the grooviest out there, would give us the same exact thing. Actually, in 3 dimensions, we don't care about 4th one. But we do need to include it mathematically. So like this. This is what we're looking for. We already know how matrix transforms work. Yeah, we do, actually. The 4th one empty. The 4th one also needs a 1 at the end. Got it. Solved it, I think. If I did it on the first try, that would be... I am so amazing. Okay. This... Wow, I did this using the graphical information from my own video. From my... Well, doing physics in 7 dimensions, when I explained matrices, using... that information, if you watch doing physics in 7 dimensions, alright? If you go to the chapter for how matrices work, then I just solved this problem using that information, using that visualization. Wow, that's incredible. Wait, so if we do like 0.5 at the very end, what's gonna happen? It's gonna be twice as big. That's cool. All right. All right. Oh, that is so cool. Can we get a clip of that? Can anyone clip that segment? Oh, no. I might clip it myself. I've never clipped anything on YouTube. Clip. All right. From... Oh, that is so cool. Wow, that's incredible. Movies out there. Would you see? So like this. This is what we're looking for. Graphical information. I'm looking for I think. Got it. Solved it. I think. If I did it on the first try, that would be... I am so amazing. Okay. This... did this using the graphical information from my own video. From my... well, doing physics in 7 dimensions, when I explain matrices, using that information, if you watch doing
There we go.
physics in 7 dimensions...
This is my first time ever clipping anything.
If you
Share a clip.
go to the chapter... Alright.
He's clipping yourself. Yeah, I am. I've never clipped anything on YouTube, so I don't know how clipping works.
Got it. Solved it, I think. This, and I explained...
Can I share a clip in it like a post? With this walk? I've never even tried sharing videos in a post. Can I share videos in a post? Video! There is a video button! Allow cookies? Yeah, fine, Google. You pay me my salary. I like... do anything you want. No matching results. Okay, so I like... okay, so I can like... I can make a clip. I just can't share it normally. Okay, fine, whatever. I can share it on Discord. The science talk. I mean, this was a pretty awesome moment. I would clip myself too. Yeah, I mean, who wouldn't? You mean to tell me I can make a clip? I can't share it. What kind of 1984 share? I can embed it. That's it. Can I not share it? Oh, what's the why? Fine. What's the point of clipping? Precisely. What's the point of clipping? I'm not. If I can't just spam all the people with myself more. Okay, that's not. The point is, we figured it out. I'm impressed with it, honestly. Now what we can do is we can go to shaders, and right here we output our color, which will be just the mod color. And then our color will go in here, and we can do this, and we can multiply it by our color, if I'm not mistaken. I really hope so. And we can actually already test if it's gonna work by just going in here and just doing 0.5, 0.5. And now if we build it, and now if we execute it, we get nothing. Fine, okay, whatever. The point, okay. All right. Okay. That's why. That makes sense. Okay, that does make sense. That explains actually why it didn't work. It's fine. Now if we build it, now we execute it, okay. Alright, that's fine. Second, 2 times the charm, you know. It's just whatever. It works. Okay, some doesn't work, some works. It's, you know. Log. Ah, I see. I forgot to input call log. Yeah, that actually makes sense. Okay, now if we build it, and now if we execute it, we get boom. It's red. And what's even nicer is that we can take the GLFW get time. We can take the color log, and we can do color log. No wait, not color log. Temp color is equal to temp color like 2 is equal to GLFW get time divided by 100, and then if we do it, if we build it, and then if we execute it, we get a slice of part slowly turning more blue. I don't know what's gonna happen if the value of blue exceeds 1. You know what, let's do it 10, because 10 will be so much quicker than 100. That's basically a minute of wait time. There. Now you can see it becoming more and more blue as time goes on. And what happens if it goes past 1? Wait, is it still going? Oh, it's just getting more and more blue. Wait, it can get past 1? Can it really? What happens if we set it to like 3? Will it really be a 3? Ah, I guess I got my face. Well, now what we can do is we can take GLFW get time function, and we can do it like
this divided by 5, and then we can do the other two with 5 divided by, so the other way basically. And now if we run it, hi the Gabriel by the way, isn't bringing its code. That's just an essential part of programming. And now we can see it just slowly going to blue. And more blue it becomes. Funny enough, I mean, okay, I know that you all joke about drinking acid and stuff, and I don't wanna, and I would first like to mention that you obviously shouldn't drink acids, because, you know, it's just bad for you. It's like chugging bleach, basically, except worse. It's really bad for you, so don't do it. At the same time, I have tasted sulfuric acid. Not intentionally, but I have tasted. It's like, okay. Wait, I don't get it. Why do you all think drinking acid is like cool or something? It's not hard to do, it's just dumb. But yeah, I have tasted it. It's really surprising. I mean, I knew that acids are sour, but it just, what it tastes like, it was sour. It was like really sour. It tasted like a not bitter, like a lemon, except without any bitterness. I mean, the reason why I find out, the reason why I tasted sulfuric acid is because I got some on my hand. I should mention, it was really low concentrated. Really low concentration. That's an orange. No, orange is sweet. It wasn't sweet. It was just sour. So I tasted really low concentration sulfuric acid, which still, I'm pretty certain is bad for my health. But I did it on accident, so... sulfuric acid lemonade. I mean, okay, the thing is, you know how like when you eat a lemon, right? It gets so sour that it's no longer good. If you taste it, like really concentrated sulfuric acid, then the sourness would just transition into pain. Which means if you start at extremely low concentration, I mean extremely low concentration of sulfuric acid, it will be sour. The more you up the concentration, it will just be pain. It won't have a taste. You won't taste anything because it will just be painful. It will dissolve your tongue. It will taste like heat, basically. Heat would be actually... yeah, so it would taste like a hot iron in the end. It's actually pretty similar. How does one drink sulfuric acid? I didn't drink it, I tasted it. That's the difference. I got some on my hand and it was... it stung a bit, so I licked it and then... what does melted tongue taste like? It doesn't taste, that's the problem. So when people say like, you know, drinking acid and such, you know, just joking around, for most concentrated acids, you wouldn't be able to taste them because your nerves would just die instantly. You would just feel pain. Why would you lick it? Well, because it was hurting me and I didn't have any water nearby. Like a normal person. It was low concentration, as I mentioned. If it was high, I wouldn't, but it wasn't high. There we go. Actually, I mean, we did a crazy lot today. Now what we can do is we can, to each one, so to each texture, also add in a transformation color. So we could have actually, oh, we can do a struct. Oh, struct would be so clever actually. Why didn't I do it with structs before? Hold on. Struct. Texture. It's like this. I don't know how structs work in C. Struct in C. Ah, that's, I see. Alright. So, the struct will basically be texture, which will be an unsigned int, and then we'll have these two, except they want and then GL texture will be just texture pointer. I'm sorry, can I not use... Oh, I need struct, so I could type def it. Would this work? I hope so. And then we have to go to init, and then in init we have to go down right here, and then this GL texture we have to do it dot texture, like this, and then each time we they were making drinking acid is bad. This button hurts. I mean, it does hurt. It would hurt if you drink concentrated. It's don't quit like saying it as if I'm trying to trick you. Obviously, it's gonna hurt. It's acid. Shape's still going crazy today. Oh, you actually got shapes. Oh yeah, that's. I don't know. Shapes 2. I don't think I'm autistic enough for shapes 2, and that's not an insult. That's just how the game works. If you get hurt by it, you need to lick it. That's a normal human response. That's a normal animal response. Alright? Have you ever heard the expression licking your wounds? Guess where it comes from? Quit acting as if I'm the weird one in this case. Just because I'm brave enough to admit, alright, that I do what I like to. That's society, man. Texture struct, and this will be texture, which will go like this. Hi Vibu, welcome. And then we just do this dot texture. No, wait, we do it differently. We do this like this, and we don't do dot texture, we do dot texture at the end. There we go, and then when we reallocate it, we do size of texture. And now it could actually work. And also GL texture like this. Oh yeah, dot textures right here. That's important. We have to replace all the GL textures with GL texture dot texture. Main GL texture. Yep. There we go. When MAKiT, how much longer are you gonna stream today? I don't know. I honestly do not know. Maybe a lot, maybe a little, we'll see. By the way, people, did I say hi? Hi. And there we go, there we go, there we go. Now right here, dot transform. Is it really called temp transform? That's not what it should be called. It should be called just transform and color. So dot transform, we set it equal to float pointer default transform is equal to this, and float. Actually, no, it shouldn't be pointer. It should be array. And default color should be 1, 1, 1, like this. And now we build it, we get crazy lot of errors, and that's because right here we have temp colors which do not exist. In reality, what we need is GL textures like this dot appropriate texture. Also, have you seen the Indiana Jones, the new one? No. Unfortunately not. GL texture color and transform. Oops, nope. Main H, that's curious. GL texture, I have texture pointer. Sorry. Can I not type def it like this? Type def struct name, type def name. That's what I did. It's because we have x10. Ah, of course, that's why. Alright. Nope, quit doing that. Build. Alright, never mind. It's not because of x10. I mean, the older ones. The Grail, you know, the scene with the winners and temple, it starts collapsing, the Grail falls, and the wind can almost reach it, but not really. Yes, I do. That's how I feel right now with the whole electron thing and understanding. I'm so close to understanding it. I would recommend trying to pinpoint exactly which part confuses you. Like the exact bit that messes with your understanding. Because there should be one. There should be like one thing which you kind of get, but almost not really. Now eventually reach it, I understand. Well, I mean, yeah, you know. There's no time limit, I suppose. I'm sorry, why is this still not working? Even when I define with extern. What's the problem? Redefinition of struct, extend, no way. I also need to do extend right there. Do I also need to do extend over there? Oh, type def doesn't make sense now. Never mind. Just type def doesn't make sense. Okay, good. Why does type def not make sense? Is it because I have to do it this way? But this way it's gonna be, yeah, extend struct, texture struct, and then we need to do type def struct texture struct texture. Which is a phenomenal line. Now it breaks, okay. And now we have to do it like this. Damn it. Redefinition of struct, texture struct. What do you mean redefinition? It's set as extend. Keep it as extend. Why is it redefining? I mean, I could just move it to init age, I suppose. Maybe this would work. That's a possibility. Nope, still breaks. Yeah, now the texture does. Damn it. Can I just do struct texture struct pointer? I did do it in the Ventum engine, so fine, I'm gonna look it up how to do it in my own code. That's gonna be so much easier. Like in extern define, I suppose? No. Where did I define main C? Did I redefine the main C? Oh, there's no way I did. Vulkan! That's right, Vulkan exists, okay. MKT up engine H, and then when we had a struct, union. Oh, I forgot. Oh, I used unions too. I just defined it like this, and it just worked. How? So I just plugged it in and it worked. Must have been nice. And then we do it as extern, because we have to. And it breaks. It should break during linking, but doesn't break during linking, which means it's just a different problem. Okay, first error. It's gonna be easier for me to find if I just clear this. The first error happens in the main H14 typedef texture struct, redefinition of struct texture struct, which means we basically take the struct texture struct and we just redefine it, which means it has to be defined previously. Included from client init, input C. That's because in input C we include main H, which has this very definition. Would Pragma 1 solve this maybe? Almost. Okay, close. Now we build it, our error is different, but that's only because GL texture has an unsigned in pointer somewhere in the init C. Right. Now it's because these don't work. I'm getting closer. I'm thinking how to do it in an elegant way, because I can do it. I mean, here's the problem. The problem is that we can't reset them equally, properly. So another way for us to do with for I int I is equal to 0, I is smaller than 16, I plus plus, and then we can do it like this, and we can have this equal to if wait, inline if in C. I'm pretty sure it was easier in Python, inline if in C. Ternary conditional operator. What a lovely name. Clearly written by a programmer who just really wants the world to know that they're clever. If A, then B, else C. Okay. Simple enough. A, so if A, so I divided by 5 is equal to I. No wait, I divided by 5 floor is equal to I is equal to 0, I is equal to 5, 4, 8, 12, then 1.0, else 0.0, and all of this in this case we want to set transform I to this, and then what we want is we want this to just be 1.0 I of 4. Now we build it, now we run it, we get nothing. Cool. Hawkwood Dark is Maximus Da Vinci Dumbledore the Great from now on. That's not the real name! Transform! Oh my goodness, color. Never mind. I thought I had my moment of genius there, but no. How about we print just person s. Can I do doing person s in this case would be pretty dumb. Person d for I in Python. Haha. Whoa, I've clearly been coding way too much in Python. And this case just I 16 and 4, and in this case we don't want I, obviously we want GL texture color I, and then build it. All of them are zeros. What a shocker. So that's the problem. All of these get set to zeros. Why? Can I just do like this? Will that help? Why did these also set to zero? That doesn't make any sense. Size of texture, yeah. Let's do the exact same thing, except in the init. Like right here. Also all zeros. Cool. There's a long name. Are they the owner of a company or something? Because in that case, that might be just a rich person, you know, a rich people moment. They do be having long names, am I right? Why isn't this working? It doesn't make any sense. Okay, you know what? Let's just increase this for loop for a second. And let's just try inputting these and see what happens. Next one annually, it's first year teaching. Oh, never mind then. I still see. Oh wait, because we're printing the wrong. Yeah, what I wanted to print is I wanted to print this. See how it looks. Also all zeros. Okay, that makes it different then. Oh, because it should be percent F. Ah, I'm such an idiot. Why didn't any of you mention that I was doing the percent incorrectly? Why did none of you mention that I was doing the percent incorrectly? That's way more numbers than I was expecting, if I'm honest. Why is there so much numbers? For sure there's more. Of course there's no. Of course there's more. There's always more. These names always... Okay. And then we divide into two, and then it's getting printed again. Oh, it's getting printed again because this is the second shaded. Actually, you know what? That makes a lot of sense. What if we print this now, except with an F in there? What do we get then? One, one, one. I know what the problem is. Oh, I know what's wrong with it. I know what the problem is. It should be 5. It should be 9. It should be 13. No, wait. It should be 6. It should be 15. It should be 10, I think. I think that's the problem. Oh, I'm so clever. Look at that. Oh, hell yeah. Honestly, I should charge you all for watching me walk. I'm just so great at this. I'm just so good at this. I should genuinely charge you for it. You all are welcome that I'm letting you watch me for free, honestly. I look like Dr. Doom. Dr. Doom. Who's Dr. Doomshot? I myself am more of a Doofenshmirtz type. Video pronouncing the name. Just where'd you get the video from? What do you mean Make's gonna charge us with him electrical chair? What? Sounds like a threat. Pretty mean of you if I say so myself. Okay, now actually we're going like crazy. We can go actually for the input and right here. Oh yeah, escape turns the window off. Now what we can do is we can it's a threat. Well, try me then! I don't respond well to threats. I mostly just threat back. You would charge us with lecture if we mentioned the funny word again. Don't charge us, we are poor. So am I! I'm just trying to exploit other people for my own benefit. What's wrong with that? Now let me just look this function up. Get key. How does it work? It works like this. Keyboard keys obviously is what I'm looking for. Alright, so we have the keys and okay, it makes sense. What we should do is we could do it one key at a time and just How should I do it in a smart? Well, I have a couple of ways to do it. Not all of them are smart, but that's one of the good MAKiT songs. Bum, ba ba bum, 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 bum. Okay, let's do it like this. Yeah, it's not gonna be good. Input struct keys input, and then right here we will have char 0 key 0 1 2 3 4 5 6 7 8 9. Actually, no, we should have it as a char array with how many keys? 10 plus letters, right? So 24. 34 then. So key. Right here we should just have input struct, and right here we should just have input. There we go. And then right here we'll have a value which will be input. What do we use for the input? Actually, you know what? Input might be a part of MAKiT. Yeah, MAKiT input. There we go. Retractable nanotech helmets, actually pretty comfy, dropping soon from Fairflow durability testing. Alright, MAKiT input, and then an input. We basically want to go through each one of the keys and then just set it, I guess. Fine, let's do it. So for Python, int I is equal to 0, I is smaller than 10, I plus plus, and then what we want is we want glfw key 0 plus I. If it's equal to press, then MAKiT input dot key I. MAKiT input. What's your problem with MAKiT input? It's right there. Undefined. I will give you one. Oh, you don't include your own header? Why don't you include your own header? Oh, but main also includes it. Oh, damn it. It's gonna be once again, it's gonna be the same problem as we had before, right? Let me see. Would you look at that? Input age 9th, yeah. Which means that this would have to be an extern, and then this would have to be inside the input. Defined. Oh, I would walk. I was not expecting. Okay. Is equal to 0. And right here, at the very beginning, we basically set everything to. We set everything to 0, then we set it to 1, and then what we do is we do What does class encoding make it? I know what it is, but I can't explain. Class is bullshit, is what it is. If you ever need to explain what a class is, just say bullshit, because that's what it is. It's basically people in programming deciding that, like, names aren't good enough, and they want to make names a part of a coding language. I'm angry with classes, I don't like them. They're idiotic. I really don't like them. It's like constant values. I've actually needed to change a constant value on 3 separate occasions, but I couldn't. Because the people who made the libraries didn't trust me with changing the constant value. It's all the constant values in classes are other people telling me what I should do with my code. It's my code, no one else's. The mole of coding. It's awful. And then you have JavaScript, which... well, not JavaScript, Java, which is basically based on thing. Taha, mamangi. Code A will look like this, and then plus I, and then I will be smaller than 24, and right here we'll have this plus 10. Yes. And now, if we do the thing, if we go to main C, if we do GL texture 0 color 0 plus equals MAKiT input key 1 divided by 10, and then minus equals key 2. Then if we build it, if we run it, if I hold key 1, okay, I'll have to press it a bunch of times now to get to work. Let's not divide. If we build it, if we run it, we can regulate just how red it should be. Isn't that cool? And then we can... sick. Well, buy the lampos, then buy. Where's the keys? Okay, where's the keys? Because this is actually gonna be pretty awesome. Not page up, only not Fs. I'm looking for... where's the arrows? Left bracket, right bracket, backspace. There we go. 263. Right, left, down, up. Right, left, down, up. Then if we go to main, if we copy this, if we go to main, right, left, down, up, then if we do GL texture 0 dot transform, and then 0 plus equals right minus equals left minus equals down plus equals up, so minus equals down plus equals up, and then we do 1 2 3 5. Then if we build it, okay, Hold on, why can't I... Oh no, that's bad. What did we change? Transform? Hold on, I'm sorry, what now? Transform. Okay, that's bad. Okay, that's pretty bad. Why is the left arrow... Why is the red arrow changing... left arrow changing the color to more red? See, that's a problem. In fact, the two objects overlap make two molecules or atoms bond. Is it because it takes less energy for them if the orbitals overlap? I'm confused. Yes, it is because... Well... Hold on, didn't I explain it in the electron video? See, that's why I mentioned I should watch the electron video, because over there... These things... That's the video in which I, well, put everything about the electron.
Negative side and the positive side. Now, but
Yeah, molecular orbital theory.
Like it's happening.
Also, I'm hold on. I'm pretty certain. Yeah, so it's that segment from the electron video where, yes, if they overlap... Well, yeah, it's basically
Bonding.
this segment, right? If they overlap, as you can see, they form the bonding orbital and the anti-bonding orbital. And the bonding orbital is lower in energy, so because of that, the entire bond is lower in energy. Because of that, they are more stable. I'm just thinking if I made another video in which I maybe showcase that a bit clearer. No, it wasn't the... Could it be the acid video?
Now, when we dissolve it in water, it forms copper sulfate pentahydrate. And what's really nice that we can...
No, that's abstract chemistry. Well, I guess just the electron video. Yep. If the orbitals overlap, they produce two new orbitals. So, if you have an orbital, s orbital, and if you have an s orbital, if they overlap, they produce two new orbitals. They produce the sigma orbital, and they produce the sigma anti-bonding orbital, like this. Now, as you can see, if you just have one electron right here and one electron right here, they both go to the lower energy place, and because of that, you have right here difference in energy. This difference in energy is, that's how, so this higher, so the bonded electron, the bonded atoms have this much less energy. This right here, this distance. This distance is how much energy less they have when they are bonded, which is good for them, because that means they are more stable. If they are unbonded, then this is their energy level. If they are bonded, this is their energy level. So as you can see, bonded atoms have less energy than unbonded. That's what makes them bonded. This less energiness. Now then put on the arrows. Arrow. Now we build it. Now we run it. Look at that. We can rescale the thing. Oh, that's so cool. Okay. Sweet. But I didn't want rescaling. Rescaling, that's a miss. What I actually wanted was... I wanted to move it around. So in order to move it right, for example... Oh, in order to move it right, we want to... Oh, that's a much harder task. In order to move it right... Would we need to add it to the fourth one? So... 3, 7, 11, 12... 12 and 13? Am I thinking about this right? I don't know. We'll have to see. I am! Okay, apparently I am. It's just that we're adding way too much. Divide by 100 at least. Oh yeah, it makes sense actually that we're adding way too much because, yeah, okay. So is anything changing or am I crazy? Divide by 5? It feels like if it changed this much at the beginning, it... How is us adding just 1 changing it so much, but us adding 1/5? Okay, well, I can work with this. That's good. That's what we're looking for, actually, yeah? Except... Damn it. Oh, we could do it like this, actually. So... There we go. 1, 2, 3... It's pushing my favorite channel. Well, I'm so glad you say that, actually. It means a lot to me. There, there we go! I'm having a lot of fun with this. Oh, this is so much easier than Vulkan. Well, actually, is it much easier than Vulkan? It's similar, now I think about this. Isn't that cool? It is cool. It's really cool. We can move objects around. And that's... Well, this is texture, to be fair. We have it inside of it. Ah, we have it inside of the texture. We shouldn't have it inside of the texture. We should have like an MAKiT object which has the texture and the shader program. No, shader data. Oh no, shaders should be separate. It's just that this shouldn't be a texture. This should be. This shouldn't be GL texture. This should be MAKiT visual object. Counted to the audio objects or whatever else we'll do in the future. Okay, but I want you to change all occurrences only if it's actually texture. There we go, and then visual object size on the very top. Right, no, GL texture. Okay, we have GL texture, right. Where do we define GL texture size? There we go, that's where we have to find it, that makes sense. Should be visual object size, because it will be a visual object from now on. So like this, there we go, and then main, just replace them all. And now if we build it, it breaks, cool. MAKiT visual object -1. Height size. It should be size, not object. Size. Size. There we go. And then in cleanup we free geotexture when we should in fact clean MAKiT visual object. And then if we build it, if we then with breaks, because MAKiT visual object is not, let me guess, right here's geotexture. Would you look at that? I'm so clever. Now build it, then it breaks because on line 64 we have this, and on line 142 we have this. Then we build it. Then we can move stuff around. No. 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 Terry, I wouldn't really call it word of the day because, like, I don't know if you've ever planned getting into programming, but it's actually quite an essential part of programming that when you try to add in a new feature, then you basically imagine the program as like a really, really complex puzzle. If you try to add in a new thing, you're trying to integrate it into that puzzle, which is a difficult process, to say the least. I mean, clearly, it took me, what, 2 hours just to get this object to move around. Now we can move around in a really clever way. Huh? I'm thinking what to do now. We could do the render loop. I am a bit tired and will take a while, so let's just instead do git add a. Git commit message image transformation, and then git push. And now let's see how much of our project is written in C. Let's see, because I said C, I'm funny. $96. Hell yeah. That's what I like to see. Mind the swarm. Anyhow, I suppose for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.